Structured query language (SQL) questions are very likely to appear in your mock and external exam. They are easy points to gain in an exam if you understand how SQL works. So what does SQL do in a database? SQL manipulates the data so that commands such as update, query, delete, insert, create, and drop can be performed on the data. SQL is used in a range of database systems, not just Access, but also LibreBase and MySQL, to mention just a few. As you work your way through this video, please make sure you have the SQL mini booklet. This will either be at the end of your database booklet or as a separate document which you will be able to download in Sector for this week's lesson. There are several key words that are used in SQL, but there are 3 words that you really do need to remember. When using SQL, these are select, from, and where. Select is used to select data from a database. In this example, we have a table called Customer Table, which has 4 fields: Customer ID, Customer Name, Phone Number, and Country. If we want to choose, say, Customer Name and Country, then we need to select them from the Customer Table's relation. So in SQL, we would write the keyword select and place the fields we want, i.e. customer name and country, and then underneath we would write from and write the table, in this case customer table. At the end of the SQL statement we will always have a semicolon. So if we wanted to select the customer ID and phone number, what would the SQL be? I will give you a moment. I am sure you would have got this correct. Yes, it would be in the select row, customer ID, phone number, and on the from row, it would be customer table. Make sure you have the semicolon to finish off your SQL statement. In this image, we have the same table as before. The only difference we have is an asterisk on the select row. The asterisk symbol is a quick way of selecting all of the fields in the table. So in this example, the SQL is saying that all of the fields have been selected from the customer table, again finishing with a semicolon. Now we will introduce our 3rd key word, where. Where is used to keep those records which meet a certain criteria. It acts something like a filter, keeping back what we want. In this example, you will see 2 tables. We will focus on the top one. Here we have our asterisk next to select. So that means all the fields have been selected. We are taking these fields from the customer table, which is why we have in the picture from customer table. The new bit is where. Here we are saying we only want the country Australia from the field country. So we say that in SQL by using the keyword where, followed by country equals Australia in quotation marks, and again finishing with a semicolon. Now let's have a look at the second table. This table is the result of an SQL query. Using the keywords select, from and where, create the SQL query to produce this result in this table. You should pause the video for a moment whilst you write down your answer in your booklet. Then start the video when you are ready. So, here is an answer. You should have select asterisk from customer table, where customer ID equals 3, which is in quotation marks. Your where row could also have had customer name equals Lisa Legg in quotation marks, or phone number equals 0477 653 153 in quotation marks, or country equals Australia in quotation marks, followed by a semicolon. Let's look at two new keywords, update and set. First of all, look at the Pat Adams record in both tables. You will notice the original record had Pat Adams living in Germany with a phone number of 0422 098 334. This has been updated to Pat Adams now living in Mexico with a new phone number of 0488 988 234. To update a record using SQL, we use two new keywords, update and set. If we use update, we will always use set. So the SQL statement says that we will update the table, customer table, and we will set the new data of phone number to 0488 988 234 and the country to Mexico. This will be done to the customer where their customer ID is 1. Always remembering to put the semicolon at the end of the SQL statement. Spend a moment looking at this SQL and make sure you understand this. In this example, we're going to update records with customer names beginning with either an R or an L using the asterisk symbol, which is termed a wildcard. We will set the country to Mexico. To do this, we will update customer table and set country to Mexico. The where row is a little more complicated as we need to include another keyword or. So any names beginning with R or L will have their country changed to Mexico. Please notice several features. Firstly, the field name customer name is used twice for the R and L. Secondly, the asterisk is placed after the letter R and L. And this is saying we are looking for any words beginning with an R or an L. Thirdly, that semicolon at the end. Now, complete your question 3 in your SQL mini booklet with the answer on this slide. In this example, we see how to add a new record to the table. We use the keywords inset into, and this is always followed by the keyword values. You may have noticed that we have not included customer ID on the insert into row. This is because it should automatically generate that number as the customer ID data type is auto number. In this example, you can see that the table was sorted on customer ID. but has now been sorted on customer name. To do this, you would select all the fields by using the asterisks from the customer table, then use the new keywords order by on customer name and put it in ascending order. So we have select asterisks from customer table, order by, customer name, ASC. ASC is ascending, that's smallest to biggest, and DESC is from biggest to smallest, and that is descending. Now, have a go with question 4 in your SQL mini booklet. Pause the video, and when you're ready, start the video again to hear the answer. Okay, hopefully what you have is this. Select asterisks from customer table, order by, customer ID, DESC. Here we see how to concatenate. Concatenation is the combining of two fields into one. On the select row, we have selected the customer ID field and we want to join together or concatenate two fields. These being customer FN, that's customer first name, and customer SN, customer surname, and put the output under a new field called customer name. Take note of the commas and speech marks on the select row. This is to ensure that there will be a space between the first name and surname. Now, go and answer question 5 in your SQL mini booklet. Pause the video while you do this, and when ready, play the video to hear the answer. Okay, so the answer is this. Select name, comma, concat, speech marks, name, comma, speech mark, a space, closing speech mark, comma, address, comma, open speech mark, a space, close speech mark, comma, city, comma, open speech mark, space, closing speech mark, comma, postcode. From address table. On this slide we are looking at calculations, namely the sum and average function. In this table we can see some figures in the payment field. Using these functions we can find the results. So by using the sum function, it will add up the figures when the SQL code is run and the result will show 480. The average function will add up the figures and divide by the number of rows. The result would be 120. You will see from the picture that the function is on the select row and is written with the function name, and the name of the field is put in brackets. Over the next few slides, we will look at a number of exam questions related to the SQL booklet. These questions are in your SQL booklet or attached to your database booklet. You need to attempt each question yourself before looking at the video for the solution. Pause the video while you have a go at question 6. In the picture, you see highlighted in yellow the key information needed, that being customer accounts contact and customers listed alphabetically. It is always a good idea as you read your exam questions carefully to underline or highlight important words so that you do not miss out on anything important and lose marks. Underneath are a series of entities. We are only interested in the customer entity. We would write the SQL to include both the customer name and customer accounts contact. We need the customer name in order to put this field in alphabetical order. So we would have search, customer name, comma, customer accounts contact, from customer, order by, customer name, ASC. The ASC is optional as the question did not ask for the names to be put in any particular order. So how do the marks break down for this question? You would get 2 marks for naming the fields, 1 mark for naming the entity, and 1 mark for being able to put in order the customer name. If you got top marks, well done. If you did not, create another SQL yourself. This time searching for the product price and product description and putting the price in largest to smallest. That's descending order. Before you start question 7, you will be asked to select several fields from different tables. To show this in the select row, you will need to write the name of the entity followed by a full stop and then the field name. So let's say I want the customer name and order date. I would write the search row as customer full stop customer name, comma, order, full stop, order date. So as you see on your slide, it says search, customer full stop customer name, comma, order full stop, order date. In the from row, I would simply put in the entities that I've used. So it would be customer, comma, order. Now, pause the video and have a go at question 7. Then come back to have a look at the solution. Here we see the important information we need in grey and where it can be found in yellow. The question mentions the customers 17th November 2014 and postcode 6000. We will need customer name, delivery date and delivery address fields. Quantity is required in the second bullet point, so we need product quantity. Delivery address is mentioned in the 4th bullet point, but we have this information already for the postcode. So now for the solution. Search, customer, full stop, customer name, comma, order, full stop, delivery address, comma, product, full stop, product description, comma, order stroke product, full stop, product quantity, comma, order stroke product, full stop, delivery date. Notice for order stroke product, I need to write out the table each time for the 2 fields needed in this entity. From, customer, order, product, order stroke product. We need to use where as the criteria in the delivery date field will be for a specific day. So where, order stroke product, full stop, delivery date equals, in quotation marks, 17/11/2014. Now, move on to question 8. And when you are ready, look at the answer on this video. The question is in 2 parts. The first asks for the purpose of the reg number field. In the car relation, this is the primary key. used to identify each tuple. It is the foreign key in the customer relation that establishes a relationship between the car and customer entity. The question says for part B, using structured query language, SQL, write a query that will list the first name and surname of all customers that have a Ford Falcon. For the second part, we need to select the first name and surname fields, as well as the car make and car model. Here is how we would write this out. Again, take note of the need to write the entity each time we state a field. So for search, it would be client full stop F name, client full stop S name, comma, car full stop make, comma, car full stop model. From client, comma, car, where make equals, in quotation marks, Ford, and model equals, quotation marks, Falcon. In this case, the marks were allocated for 1 mark for the correct selections, 2 marks for the tables in the from row, and 2 marks for the correct criteria in the where row. When you are ready, have a go at question 9. And when you are ready, use the video to look at the answer. To save on space, I've written the tables out in short form from what is in your SQL mini booklet. Part A. Write the SQL to identify all the members who live in Leaderville, ordered alphabetically by their second name. We need members in Leaderville ordered on second name. You can see from what is highlighted in yellow the fields that we need: first name, second name, and suburb. Here is how you would write it. Search, first underscore name, comma, second underscore name, comma, suburb. We do not need to write member dot first underscore name, comma, member dot second underscore name, as we only need the name from this one table. So from member, where suburb equals Leaderville, order by second underscore name. The point allocated in this question would be 1 mark each for the search, from, where, and order by row. Part B. Write the SQL to identify all the members who have chosen the annual package and live in Leaderville. So we need to know the members who have the annual package and live in Leaderville. The fields shaded in yellow are the ones that we need. The solution is search. Member full stop, first underscore name, comma, member full stop, second underscore name, comma, member full stop, suburb, package full stop, type. From member, comma, package, where type equals annual and suburb equals Leaderville. You would get 4 marks for the search row, 2 marks for the from row, and 2 marks for the where row. When you are ready, have a go at question 10 and check back with the video later to have a look at the solution. Here we have in shortened form the 2 tables for question 10. Using simple query language, write a query to list all of the first and last names of the contacts that belong to the suppliers that reside in North Perth. Here we need to find the contact names of the suppliers that are located in North Perth. The solution would be search, contact, full stop, first name, comma. Contact, full stop, last name, comma. Supplier, full stop, supplier name, comma. Supplier, full stop, supplier suburb. From, contact, comma, supplier. Where, supplier suburb equals, in quotation marks, North Perth. Question 11 is a short one. When you think you have the answer, have a look at the video. Here is question 11. Conditions are used in algorithms. The condition below can give different results. How? Our algorithm is age more than or equal to 18 and sex equals male, or qualification equals degree. The two possible results returned could be 1. That you have to be over 18 and male. The second possible result would be you have to be over 18 and have a degree. Now, for the last question, question 12, have a go at it, then come back and have a look at the solution. Here is the table. Customer, in brackets, cust ID is the primary key, first name, last name, address, suburb, phone. Write a query that would search the customer table for the names of all people who live in Midland. So we want to know people's names who live in the Midlands. Here is the solution. Search first name, comma, last name, comma, suburb, from customer, where suburb equals Midland. In this case, the marks would break down to 2 marks for the search row, 1 mark for the from row, and 1 mark for the where row. Let's do one more bonus question. Using this ER diagram, write a query using SQL that will display bands that were around from the 1st of the 1st, 1980 to the 1st of the 1st, 2019, with the following information: band existence, band name, title, number. Pause the video, and when you are ready, have a look at the solution. The solution is select band, full stop, band name, comma, band, full stop, band existence, comma, album, full stop, title, comma, track, full stop, number, from band, album, track, where band existence equals more than or equal to the 1st of the 1st, 1980, and less than or equal to the 1st of the 1st, 2019. Thank you for watching this video. If you are still unsure how to do SQL, please go and see your teacher, who I am sure will be happy to help you. Thank you for watching this video. Bye-bye.